In the next page of our notes, these two need to be trimmed up so that you can fit it on one page. And at the top, I want you to go ahead and title this page Discrete and Continuous Functions. So these are actually topics on their own. And actually, whenever I was in college, I took a discrete math course. It was strictly about discrete math. I didn't realize that until I was thinking about it this morning. But there is a whole field of math just dedicated to discrete functions. And then there's another field just about continuous functions. So let's talk about what discrete and continuous mean. A discrete unit is indivisible. So let's think about what indivisible means. Y'all have heard that word in the pledge, right?
Cannot divide it.
Cannot be divided, right? We have a
So smart, Gunner.
state that cannot be divided, a country that cannot be divided. So what does this mean about a discrete unit? The unit cannot be divided. So whenever we say cannot be divided, there are no partial parts. No partial units. Like 1.5 puppies. Can you have 1.5 puppies?
Yeah.
No, you cannot. You cannot. You cannot have partial units. We are blank things that are discrete, or we count things that are discrete, like puppies. I would go out and count how many puppies that my dog had. So that would be discrete. A collection of discrete units will be graphed as a scatter plot. So let's say I am breeding boxers, boxer puppies. So my female dog would give birth to so many puppies, her first birth. Then her second birth, she would give so many puppies. So each time you are able to make a scatter plot of how she is having babies, how many puppies she's having. It is, you can't connect the dots because just because she had 5 puppies her first litter doesn't necessarily mean that you can connect to that next point. Like her second litter, she had 2 puppies. You wouldn't connect those because there's no relation between her first litter and her second litter. For example, puppies born, or puppies in a litter. Or games played. Or snow cones bought. So those are examples of discrete functions or discrete variables. Last night, they were giving away snow cones.
Where?
They counted in order to pay for the snow cones. The people told them how many they gave away. That was at the Meet the Devils. If you went, Booster Club paid for all that. So they don't the company, what's the company? Chills on Wheels.
Oh,
Didn't tell the Booster Club I sold 120.2 snow cones. That wouldn't make sense, right? They counted how many snow cones they had and then charged the Booster Club for that. So you can't say you got 120.2 snow cones. Doesn't make sense. So you got to think about, does it make sense as partial pieces, or is it just whole numbers, no partials? The graph of a discrete function will be made up of coordinate pairs that do not connect to each other. Do not connect together. So when you have points that are graphed, you have a scatter plot. They do not connect. So this example is X is innings, Y is number of runs. So this is baseball or softball, right? Whenever they have the scoreboard up there, do y'all know how the scoreboard is drawn up, or how it looks? It looks like this, right? Well, it actually has two, right? So it's like first inning, CH got 3 runs, right? And then whoever, let's say Mount Vernon, got 2. Second inning, Chapel Hill got 2 more, so that'd be at 5. Mount Vernon got 0. But wouldn't this just be 2? Do they add up at the end, or do they add up here?
They add up at the end.
Oh, my goodness. Okay. So total would be here.
Yeah.
So I could say 2 there. And I could say they got 5 here. So it counts whole number of runs. It counts whole number of innings, right? So that's how we know it's discrete data. I'm going to put a 0 here. See, I'm not a softball player or baseball player. I play basketball. All right, so let's move on to the other type of function, which is called continuous. Continuous whole. So discrete it can be divided. So continuous, or can't be divided. So continuous means it is divisible. So continuous whole is a set of all numbers on an interval. An interval like 0 to 100, like your grade in class. So that would be includes partials or partial units. Your grade is rounded, right? So if you have like an 82.5, it's rounded up to an 86. But, oh, yeah, I was thinking 5. So 80, what did I say?
82.5.
Okay, so 82.5 would be rounded up to 83. There we go. But you could still have partial, right? Whenever you look at your grade, you can see partial. And your grade's going to continuously either go up or go down. It doesn't just magically do that. It's continuous. So consider the distance from A to B, like 0 to 100. Your grade could be anywhere between those two numbers. That's what an interval is, A to B. Between A and B, it continues. So anywhere along here. So it could be 99 right here. It could be super close to A. It could be anywhere along there. But the dots are connected.
Through the line.
Through the line, yeah. So discrete, we could count them. But we cannot count how many numbers are between A and B. That's an infinite number of points I can plot between A and B. You can't count infinite. You can't count to infinity. So there is nothing to count. As we go from A to B, the line continues without break. Since the length from A to B is continuous, we can take any part we please. For example, what would be an example? Let's say A is 0, B is 100. What's an example that we could have of a number between 0 and 100?
50.
50. We could have 50.0002. What could we have?
99.9.
99.9. Exactly.
47.
We could have whole numbers. Okay, so we have some examples there, but there's an infinite number of examples or numbers between 0 and 100. We can't count them all because it's continuous. It continues between 0 and 100. Therefore, we say that continuous functions are for, let's do time. So an example would be time. Time continues on, right? So time doesn't just hop from 0 to 5. What about number of gallons? Let's say I'm filling up my pool. Does the pool level start at 0 and then all of a sudden it's at full?
No.
What do you notice about how the pool rises?
When the water is turned on.
Slowly, water gets turned on. It's going to continuously rise. It doesn't go from being half full to whole full all the way. It is a continuous filling of that pool. The graph of a continuous function will be made up of coordinate pairs that do connect together to form a line or a curve. So we have a continuous line starting at 0, 2 and continuing to infinity.
Is there one that we can do that stops?
Yes, yeah, you could still do. Remember the number line when we did inequalities? You could actually have where we are just going from 0 to 5. And it starts here, stops there, and it's everything in between. That's still on an interval. It's just between 0 and 5, but this would still be continuous because it continues between 0 and 5. Okay, so go ahead and glue these in. Let's look at the next foldable that we're going to do. Look at the front. It says discrete or continuous. Determine whether each relationship represents a graph that would be discrete or continuous. So I'm going to let you work with your table group on this. I'm going to give you a few minutes. There are 3 of each. So let's go over how y'all did. So number 1, Kinsley, what did you decide?
Discrete.
Okay, why?
Because you can't keep on. It's just cookies in a bag. You can't count forever. You put a certain amount of cookies in the bag.
Can we count partial cookies?
No, you can't have half of a cookie.
Right. That's good. All right, the next one.
Continuous.
Okay, why?
Because it's not at the end of how old the giraffe is. As it grows, so it'll continue getting taller, longer.
Yep, the word, it continues to grow. Exactly. All right, the next one.
Discrete.
Okay, why?
Because you can't have half a student.
Good. All right. Next one. Distance traveled over a period of time.
Continuous because it's time. Time never stops.
Yep, it continues on and on. And what about distance?
Oh, distance. Distance goes on.
Yeah, distance goes on and on too. All right, the next one.
Discrete.
Okay, why?
Because you can have half a kit.
Good. All right, the next one. Weight of gallons of water.
Continuous.
Okay, why?
Because continues to change.
Yeah, so let's say I have a bucket on a scale. I'm going to continuously pour water in that bucket that's on the scale, and you'll see that the weight goes up. The gallons of water is also increasing. All right, good. Let's go to the next page. So you're going to do this with your table group, both viable solutions, so possible solutions, and then you're also going to do equations and types of graphs. So you're going to work with your table group. Make sure you read everything. You're going to answer the question. It says, is it possible? Answer that. And then it says, what does this mean for our x values? You have to answer both questions. So it's a yes or no, and then explain what does this mean for the x values. Okay, as you're working with your group, make sure you finish all of this, or if you're working alone, finish all of this and all of this. When you write your equation, you can use any variables you want, or you can use y and x, like y equals mx plus b, if you decide to. You can also do y equals b minus mx, or however you choose, or y equals mx minus b. Or if you have a negative amount here, you could have y equals negative mx plus b. So there's many different ways. So you have to decide whether your rate is positive or negative, and whether your initial amount is positive or negative, and write it as an equation. If you decide to use another variable like t for total cost, r for rides, you can do that as well. But you are going to finish this whole thing, glue it in, and we will talk about it the next class.